The polyamides then are virtually identical type of polymerization to the polyesters, with the exception that instead of using an alcohol, we're using an amine. And again, it's probably better for me to kind of highlight the chemistry that you've done already and see how it all connects together. So remember, crikey, what's happening there? To get a polyamide or an amide, you need an amine, which we've just done. So there's an amine and a carboxylic acid. And just like before, we would cut it here and we'd cut it there. There's our condensation, the elimination of water. Okay. And again, just like before, there's no reason to that we couldn't have a carboxylic acid at the other end of this molecule and another amine group at the other end of this molecule here. And when we cut that off there, cut this off here, we've got two different monomers. So we've got a dicarboxylic acid and we've got this time a diamine, which when this forms, I'll put the bond back in there. So when the bond forms between these two, I've got my amide, which is joining this together. So I'd have an amide here, but I'd also have one at this end and at this end here as well. So because I have an amide link many times over, joining two different types of monomers, we call it a polyamide. So in here, you can see that we've got our amide here, which is the link that is going to join it together. And out of here, this is where the water has been eliminated. An example with the two monomers, just like I've talked through here, is with a dicarboxylic acid, where we lose an OH off the carboxylic acid and we lose one of the hydrogens off the amine, which gives us an amide here. Whatever's here will go in there, and whatever is here will go at this point here. So again, just like the first type of polyesters, we can end up with a long repeat unit. And there's an example here, nylon 6,6, and it's called nylon 6,6 because the two molecules have 6 carbons in, so that has 6 in. This has 4 there and 1 at either end here. So the OH comes off there, the hydrogen off the amine, OH off there and off the amine, which then gives us this long repeat unit here. This bit is here, and this bit is over here. And again, you can think about this as kind of carriages on a train where you've got your dicarboxylic acid, which has a hoop at the front and a hoop at the back. And then you've got your diamine, which has got a hook at the front and a hook at the back. So they join basically there. And just like before, there is an alternative way that they can join. There is an alternative way where you could have a hoop at the front and a hook at the back, where you've got a hoop at the front and a hook at the back. So you'd have a carboxylic acid at one end and your amine group at the other end. Okay, so these are the two ways. So number one, dicarboxylic acid, which we've got here, and a diamine, which we've got there. Or the second way is where we have a molecule with an amine group and a carboxylic acid group at the front and the back end of the molecule. So going back to this then, so the example that we've got here is where obviously we've got a dicarboxylic acid and a diamine. So this is one of the ways that we can make the polyamide. Okay, and there's just some more examples here. Kevlar, this is one that you do need to know. And again, just to kind of go through the chemistry, take the O, take the OH off. There we go. Take the OH off, hydrogen off there. And this gives us a really long repeat unit here, okay? So this is one of the ways that we can do it. So each of these, so two monomers, a diamine and a dicarboxylic acid. Alternatively, we could use a monomer which has an amine at one end and a carboxylic acid at the other end. And the natural versions of these are alpha amino acids. And this is kind of how alpha amino acids join together. It's just a condensation polymerization, which comes off the carboxylic acid. One of the hydrogen comes off here. And because these two molecules are the same, there's our repeat unit. So when we have one monomer of an amino acid, we don't actually see the amide linkage in here, okay? And you can see here, look, in this molecule here, you know that the amide link is there, but it's kind of in this part and this part here. Another example of this is nylon 6, where you've got the same molecule, so 6 carbons long, 1, 2, 3, 4, 5, 6 with the one there. Carboxylic acid at one end, amine group at the other end. So this is your hoop and your hook on your carriage here. And again, condensation, there's your water that is being eliminated, which then gives you a smaller repeat unit. So this is called nylon 6 because it's one molecule with 6 carbons, and it has an amine at one end and the carboxylic acid at the other end. Just a point to kind of think about here is we know that when these polyamides form, that we have, I'll draw that as if it's going on, hydrogen there as well, C double bond O, HO at the back here. We know, don't we, that when we do this, we're looking at the OH is coming off the carboxylic acid and the hydrogens that will come off the amines. But of course, we know from the amines and also the derivatives of the carboxylic acids that these don't have to be an OH. It could be a Cl, which would make it an acid chloride. It could also be an acid anhydride, which would have another O. I'll draw it, CO, and then an R group down here. So, you know, these two things, just to be aware of when we're doing polymerization to make the polyamides, that it is not unusual to see derivatives being used instead of the carboxylic acid. So going back to this then, so there's our example, and just a couple of examples here really. So same process occurs all the time, OH, hydrogen, OH, hydrogen. Because it's the same molecule, I've got a short repeat unit. Here I've got different, so OH off here, hydrogen off there, OH off here. So I have a longer repeat unit now. And there is my amide link there, whereas my amide link in the one above would be at this point here. Okay, and again, some questions for you to have a look at. Just to finish this off and do a comparison against the type of polymerization that you've done before. In year one, we looked at addition polymerization, which was the carbon-carbon double bond. And just to recap on that, remember we have carbon-carbon double bonds, move all the groups out the way so that only the carbon-carbon double bond is in a kind of row next to each other. And then what we do is we break one of the bonds all the way along, and then we join them all up, and there's nothing given off here. So basically what we're doing is we're adding that to that to that. So we call this addition polymerization, and whatever groups you've got coming off each carbon in the carbon-carbon double bond is what you're going to have in your repeat unit there. Now this is just a recap, hopefully you can remember this. So examples of this then, if we have propene, we make polypropene. And you can see the only difference here is the removal of the pi bond, that second bond, and then we extend those bonds out because that is what repeats over and over and over again. Just to do a comparison really of all of these, because there's two types of polymerization now that you have done. Number one is addition polymerization, which is only when you have a carbon-carbon double bond, and the linkage is a carbon-carbon single bond, as that pi bond opens up and joins to another carbon. The second type of polymerization is condensation polymerization, of which there are two types. There's the polyester and the polyamide. For each of these, they can be made using either two monomers, a dicarboxylic acid, and for the polyester a diol, and the polyamide a diamine, or with one monomer. For the polyester, that would be a hydroxycarboxylic acid, and for the amide, that would be an amino acid. Okay, and we'll do that one another day.